G'day, and welcome to Navadia. Hey guy everyone, I'm going to talk about something a bit sad, but also something a little bit exciting. So unfortunately, we have all heard about the Great Pacific Garbage Patch. It is a collection of marine debris in the northern part of the Pacific Ocean. And what that means is that basically it's a huge collection of plastic, more than twice the size of Texas, or 3 times the size of France. The majority of that comes from land refuse, while some is discarded waste from boats. Unfortunately, plastic, as we all know, does not biodegrade, yet breaks down further and further to become microplastics, which are millimetre-sized or smaller pieces of plastic. This plastic waste is of course destroying the environment and is becoming an ecological and eventually will become a financial disaster. Because not only does it kill wildlife, it can also disrupt the growth of algae and phytoplankton, which are basically the bottom of the food chain in the ocean and one of the biggest producers of oxygen on the planet. If algae and phytoplankton collapses, the ripple-on effects will be disastrous, quite possibly collapsing parts of our food webs as well. The ocean, unfortunately, is pretty important and we are trashing it. However, not all things are bad. There are some things we can do to reduce our plastic waste, such as using reusable bags. In 2009, the state of South Australia banned single-use plastic bags on the 4th of May. Then the Northern Territory did so on the 1st of September 2011. The Australian Capital Territory followed on the 1st of November of that same year. Tasmania followed suit 2 years later on the same day. Queensland and Western Australia also jointly banned them on the 1st of July 2018. And on the 1st of November 2019, Victoria had banned them. New South Wales are slackers and they have yet to ban plastic bags, so tut tut. Other things that we can do is to use reusable cutlery, so we have our own little travel pack and take it with us in our bags, so if we go out and buy something, we use our cutlery rather than the plastic stuff. We can also purchase plastic alternatives such as biodegradable plastics, although, to be fair, there are some controversy around some of these plastics, and avoiding plastics in general where you can, and obviously recycling. Other ways you can avoid plastic is by using reusable coffee cups. Did you know that paper coffee cups are actually non-recyclable because on the inside of the cup there's a plastic lining to stop the cup from falling apart while you're drinking your coffee? I'm seeing more and more people becoming aware of the issues of plastic, and this is great. I'm actually really excited to see that this is happening. Unfortunately, there seems to be a couple of examples where plastic waste reduction in other areas of life has not been as good, or in fact, worse, in some ways. For example, the packaging of fruits and vegetables seems to become a lot more frequent. For example, I've even seen bananas being sold in plastic cartons and I'm thinking, these are bananas. Another example is that I saw on the news an article on Japan's use of plastic in packaging such as individually wrapped biscuits and individually wrapped pieces of fruit with up to 3 layers of plastic on melons and pineapples. In fact, Japan is the second highest users of plastic packaging according to the United Nations Environment Programme after the US. However, Japan is trying to turn this culture of plastic overuse by reducing their plastic production by 25% by 2030. Look, I'm not attacking Japan on this. I understand this is a cultural thing, but that's just an example of where plastic is being overused. Some other examples in Australia, in certain situations, they're using plastic bottles where they shouldn't be used, such as in cafes. So in some ways, we are taking steps in the right direction, but in other ways we are not, or even a couple of steps back. So yes, Meredith, but how is this relevant, you tree-hugging hippie? Yes, I may be a hippie, but there are hippies, and there are hippies that use science as an excuse for being a hippie, and I do believe that I firmly am in the latter category. Well, I've already touched on the horrors of plastic in the environment, and you've all probably heard the statistics about how there will be more plastic than fish in the oceans by 2050. This claim is actually a little bit more nuanced than the single sentence can explain, but however, it doesn't take away the fact that there's going to be a lot more plastic in the ocean than there should be. In 2008, they even found a plastic bag at the bottom of the Mariana Trench, which is terrifying. This is not okay. In January of 2013, PLOS One published a paper on the endocrine or hormone disrupting properties of plastic, mainly bisphenol A, which is known as BPA. That's why you're always seeing no BPA labels on reusable plastic bottles now. Other endocrine disrupting plastics that this paper also identifies are bis-2-ethylhexylphthalate, or DEHP, and dibutyl phthalate, or DBP. What they did is they introduced these plastics to embryonic rats, and they showed that in the first, second, and third generations of the rats that were exposed had gonadal diseases such as testis and ovarian disease, as well as obesity, diabetes, and other myriads of health problems. I have, of course, linked the study below if you would like to read this. While I know this is a depressing subject, I thought I should talk about something that is actually really exciting in our fight against plastics, because science is cool. And I am not, evidently. So what is a plastic? Well, it's a polymer. A polymer is a long repeating chain of molecules. All plastics are polymers, and quite a lot of polymers come from nature. For example, cellulose is a polymer, and it is the structural molecule of plant cells. PET, our most commonly used plastic, looks like this. The bracket means that one section of the polymer, aka the monomer, is being repeated and they link together. So if you want to use an analogy, you can consider a train carriage is a monomer and the train itself is a polymer. In May 2018, the scientific journal Proceedings of the National Academy of Sciences of the United States of America, or the more easily pronounced PNAS, published an article on the degradation of plastics by a recently discovered and artificially improved enzyme that is created by the microbe Ideonella Sakaiensis. And yes, before you ask, PNAS is a very well-respected scientific journal. It has one of the largest impact factors that I have seen in a while. It still has a while to measure up to nature, but it is definitely a lot larger than other journals that I have seen. If you are unsure on how impact factors work, I suggest that you look into it. It will help you to improve your critical thinking. I have linked a video here, somewhere, to introduce you on how to pick a good scientific journal. Getting off the subject of the quality of PNAS's impact factor, I want to talk to you about this groovy little microbe. Ideonella Sakaiensis is in the phylum of Proteobacteria. It is gram-negative aerobic, non-spore-forming and rod-shaped microbe with a single flagellum which it uses to move. Its preferred pH range is 5.5 to 9 with an optimal of 7 to 7.5 and a temperature range of 15 to 42 degrees Celsius with an optimal range of 30 to 37 degrees Celsius. Alright, you probably need a little bit of background information. An aerobic bacteria requires oxygen to do what it needs to do, as opposed to an anaerobic bacteria, which may even get killed by oxygen. Gram-negative bacteria means that it has a peptidoglycan layer in the cell wall. What is meant by non-spore forming is that some microbes are able to form little packets in their cell during times of stress, which allows it to store its DNA, and once conditions become more favorably, they basically can reincarnate themselves. Ideonella Sakaiensis creates a circular smooth white colony, and it is also a chemoautotroph. So what that means that it uses its energy from the oxidation of inorganic compounds, and they use this chemical energy to produce its carbohydrates. An inorganic compound is either a compound that doesn't contain carbon, or it contains carbon but it doesn't have any hydrocarbons, which are carbons bonded to hydrogen. That's why carbon dioxide and carbon monoxide are considered to be an inorganic compound. That is important information for later. Sakaiensis 201-F6 uses an enzyme called PETase to hydrolyze polyethylene terephthalate, known as PET, which is our most common plastic. PETase also hydrolyzes the intermediate molecule mono-2-hydroxyl ethyl terephthalate acid, or MHET. Hydrolysis means to use or add a water molecule as a way to break chemical bonds. The MHET is then further degraded by hydrolysis, or adding a water molecule, by another enzyme called MHETase, which is bound to the outside of the microbe through lipids, or fats. Both of these enzymes are required to enzymatically convert PET into two environmentally friendly monomers, so those train carriages I was talking about, which are terephthalic acid and ethylene glycol, which the microbe then uses for growth. If you're wondering what a hydrolysis reaction looks like, it basically sticks a water molecule onto another molecule, which then breaks the bonds of the original molecule. One OH goes to one side of the broken bond, and the leftover hydrogen goes to the other bond. That's basically it in a nutshell. There are different ways for hydrolysis to occur, but I'm not going to explain acid or base hydrolysis or enzymatic hydrolysis because I don't want to drown you in information. It is useful to note that usually hydrolysis does require an ion catalyst or an enzyme to work. Ideonella Sakaiensis was found/isolated in a bottle recycling facility in Japan in 2016 by researchers led by, whose name I'm guaranteed to ruin, Kohei Oda and Dr. Soshuki Yoshida of Kyoto Institute of Technology, and another person's name, who I'm going to ruin, Kenji Miyamoto of Keio University. They hypothesized that microbes will have evolved in some way to break down PET because it's so ubiquitous around the planet. Previously, only a few fungal species were known to degrade plastics, such as Aspergillus tuberogensis, which was discovered by the researchers at the Chinese Academy of Sciences Kunming Institute of Botany in 2017, which destroys PET, and Pestaloziosis microspora, which I probably ruined, which also breaks down polyurethane. There is also a pest in beekeeping called the waxworm, which is the larvae of the wax moth. Its ability to degrade plastic was discovered by a scientist and amateur beekeeper, Federica Bertoccini, when she was removing the pest from her beehive and placing them in a plastic bag. When she went to throw out the bag, it was full of holes and a lot of the larvae had escaped. This led her to collaborating with scientists at the University of Cambridge to discover how they did it. Luckily, they discovered that the degradation was chemical and not mechanical, which means that they didn't need the pest to be alive to break down PET. That is excellent news for bees worldwide, as they are currently under extreme stress from disease, climate change, pesticides, and other factors, and of course, the last thing they need is the wholesale breeding of one of their main parasites. By the way, just to be clear, Federica did not discover the waxworms, just their nomming abilities. So that's the microbes, and you have to admit that's pretty damned cool, but what does this mean for the future? Well, not much at the moment. It is a relatively new mutation. Scientists know this because they were able to accidentally create a more effective version of the enzyme. As you can understand, the longer the enzyme has been around, the better it is as functioning, as evolution has had more time to perfect said enzyme. It is very rare for biochemists to make enzymes that work better than the ones found in nature. However, it doesn't mean that this enzyme is extremely good at its job in a commercial or industrial setting. Most promising technologies do work well at the small scale, but on the large scale, they often have logistical difficulties that make them unviable. A good example of this is penicillin. Alexander Fleming initially couldn't make enough to help in the war due to its low yield. In the case of Ideonella Sakaiensis, this degradation of PET might be too slow to make any real difference. Also, the microbes work best at 30 to 35 degrees Celsius and a pH of 7 to 7.5, so it may actually take a lot of water and energy to keep these microbes doing their bit for the environment. There is also a bit of a downside due to the fact that PET is our most common plastic. We actually rely really heavily on it for pretty much everything we do. From computers to furniture to clothing to food storage, it is everywhere. If scientists mutate these microbes to the point that they can degrade plastic on an industrial scale, i.e. very quickly, and they accidentally get released into the wild, our society is in a bit of trouble. Commercial quantities of the enzyme may become available if scientists discover a way to produce it. However, there will be an issue with this too, because producing the enzyme would require any setup to be plastic-free to create, and as you would imagine, storing it would require non-plastic storage, which is actually easier said than done. Even if they did store it in glass containers, transportation would be dangerous due to potential breakages or leaking. Other issues is that Ideonella Sakaiensis is a mesophile, or a microbe that lives in relatively sane conditions. So, for example, 20 to 40 degrees Celsius, neutral pH, sea level pressures, low salinity, those kinds of things. What is comfortable for us is actually comfortable for them. This means that this microbe will be happy to live wherever we are living, which means that it could travel around the world with us. There are some microbes that get their energy from radioactive sources, and therefore they're happy to stay where they are. So, for example, we might be able to use them to clean up radioactive waste, and they cannot contaminate outside of a certain level of radiation. Ideonella Sakaiensis, on the other hand, may be able to spread worldwide if the conditions are right. I'm not saying a blanket worldwide, but I'm talking about major hubs like cities, for example. However, don't give up. Scientists are working on this. Considering that every piece of plastic that has ever been made that has not been incinerated is still on this planet. This is extremely good news for our beautiful, beautiful world. Scientists are amazing, and so are microbes. So remember, have fun, and scandium, iodine, nitrogen, and cerium. I just want to say a very special thank you to my wonderful patrons who help support me and my channel. I just want to say an extra special thank you to my $10 Redback Spider patrons, Aided Furball, Lauren Hart, Amanda Vogue, Ross Devereux, and Mary Civitano. I also want to say a special thank you to my $20 Platypus patron, Atheist Pastor, and my $35 Irukandji patron, Jasup G. I hope you enjoyed that video, and please support bacteria. They truly are the only cultures some people have.